first lesson on probability is talking about predictions. So probability is really helpful when we want to make predictions about something that's going to happen in the future. So we're going to go ahead and get started. Please follow along with your handout, and please feel free to pause at any time if you need, or rewind or raise your hand if you have any questions. So when we make predictions, these predictions are always and should always be based on the theoretical probability. So if it doesn't specify, we're thinking theoretical. In theory, what should happen? What's the probability? Experimental probability can be used for predictions, but it's only calculated when it's specifically asked based on the results, or what is the experimental probability. So let's look at the spinner first. When we are asked to predict how many times an event will occur, we are going to use proportional reasoning. So remember, back to proportions, we have two ratios set up equal to each other. You do not need to write this. We used word ratios, and if there were no words, we would cross multiply. Just a reminder, 3 times 10 would be 30 equals 4x, and then we would divide by 4 on both sides. Alright, so that's the reasoning that we're going to use. We're going to use proportions with probability today. Alright, so looking at our spinner right here, the question says, for example, one spin, on one spin, what's the probability of of landing on an elephant? So that's our first question. So we count. We have 1, 2, 3, 4 elephants. Out of how many possible outcomes? Well, 1, 2, 3, 4, 5, 6, 7. Okay, so that's my theoretical probability. You always start out with the theoretical probability on that one event. So they were asking us for the probability of landing on an elephant. So landing on an elephant would be 4 out of 7. Now, the prediction part comes in. We set up another ratio. It says predict the number of times we will get an elephant with 210 spins. Okay, so remember the top right here, the numerator is talking about elephant. I'm going to abbreviate elephant. And then the denominator is talking about like the total possible number of outcomes. So there's 7 things on that spinner. Okay, so if we are looking for how many elephants we're going to get with 210 spins, where do you think we're going to put the x if we want to know how many times we're going to get an elephant? Well, we're going to put the x on top because the x is in line, or the numerator is in line with elephant. Okay, so we want the x to be in line with elephant. Now, we're going to put 210 on the bottom because it's the total number of spins that we are going to do. Alright, so here comes the cross multiplication part. I want you to cross multiply 4 times 210 and 7 times x. Go ahead and pause this video and compute that part. Alrighty, so hopefully you got 120 times it's going to land on that elephant out of 210. Now, if you're not sure how I got that, please feel free to raise your hand and ask. Okay, so we're going to use that same thought process and that proportional reasoning in all of our prediction questions. So when it says the best prediction or what is expected, you know that you're going to be setting up a proportion. Alright, so let's at number 1. Elizabeth flips a coin 20 times and it lands on heads 5 times and tails 15 times. So when they tell us how many times it's heads 5 times and tails 15 times, we think to ourselves, okay, that's experimental. They're telling us what happened, like the results. Okay? If she flips that coin 100 times, what is the best prediction for the number of times that the coin will land tails up? Okay, so we think to ourselves, does it ask anywhere for experimental probability? No, it doesn't. It just says what is the best prediction. It doesn't say based off of her 20 recent flips, okay? It doesn't say anything about experimental probability. So we get to ignore that information. Now we go ahead and set up our proportion. Okay, so we're asking for the number of times the coin will land tails up. So we say number of tails on the numerator over number of outcomes. Remember, this first ratio is going to be my theoretical probability of landing on a tails. Well, we know that there's one tail and there's two outcomes. Landing on a tails on one flip would be half. But we want to find out if she flips that coin 100 times, how many times is it going to land tails up? Okay, so go ahead and cross multiply 100 times 1 and 2 times x. Then you would divide, and we would get 50 times would be our answer. Number 2, if we spin the spinner 300 times, how many times can we predict it would land on an even number? This time they don't give us extra numbers, which is always nice. So we are spinning it 300 times, and we're looking for how many times of those 300 it lands on an even number. So first we want to do our theoretical probability ratio. So we would say, how many even numbers are there on that spinner? Well, 2 is an even number, and 4 is an even number. So there are 2 even numbers. I'll write even, or E for even. And then how many total, T for total, how many total numbers on that spinner? There are 4. Okay, so we have 2 over 4 equals, well, we are looking for how many times it lands on an even number, so x goes on top, and 300 times spinning goes on bottom. You can pause the video and go ahead and cross multiply to solve for x. So x should be, if you solved it, 150 times. It's going to land on an even number when you spin it 300 times. Okay, number 3, if you toss a die numbered 1 through 6, 640 times, that's a lot of times. How many times do you expect it would land on an odd number? So thinking of a dice, 1 through 6, we're looking for odd number. Odd number over total outcomes. Okay? So for the theoretical probability of one roll, how many times can you land on an odd number? Or how many odd numbers are there on a dice? There are 3 odd numbers on a dice and 6 possible outcomes on that dice. We set that up equal to, we're looking for how many times we expect it to land on an odd number, over 640. I want you to go ahead and cross multiply again. Please pause the video. So you should get 320 times it's going to land on an odd number. All right, number 4. Sophia has a bag with 3 purple marbles and 4 blue marbles in it. What is the best prediction for how many purple she will draw from the bag if she draws 280 times? All right, so we got Sophia and this bag of purple and blue marbles. We're looking for the best prediction of how many purple. Okay, so we're looking for purple over total. What's the theoretical probability of her picking a purple out? Well, there are 3 purple. And how many total marbles? Well, 3 plus 4 is 7. So 7. Of one draw in that bag, she would pick a purple out 3 out of 7 times. Okay? Then we do our prediction part. What is the best prediction for how many times she draws a purple? We don't know. If she draws 280 times. Go ahead and pause the video and solve for x. You should get 120 times that she's going to pull a purple out. Okay, and the last question on there, just a little bonus. Ella picked some apples at the orchard. For every 8 apples she picked, 1 had a worm in it. How many apples can she predict to have worms if she picks 64 apples? So we're going to look at the theoretical probability first. So we're talking about how many worms and how many apples. So we have 1 wormy apple for every 8 apples he picked. Again, that's the theoretical probability, 1 over 8. Then it says how many apples can she predict to have worms if she picks 64 apples. So she's picking a total of 64, and we're looking how many have worms. Okay, I want you to go ahead and solve, cross multiply and solve for x. What you're going to do once you're done with this is do the 4 you-try problems. I would like you to work as quickly and efficiently as possible. Raise your hand when you are done or you have a question, and we will check. Once you finish, you can move on to the second video.